Finally, we're talking about classification of chemical reactions. Here we go, starting now. So you're going to write this down right here. A chemical reaction is a process that involves changes in the structure and energy content of atoms, molecules, or ions, but not their nuclei. So a chemical reaction involves a chemical change. And I outlined for you 4 or 5 different types of evidence that point you in the direction that a chemical change has occurred. What piece of evidence do you get from this picture? Light. What piece of evidence? Yes, it is a glow stick. And a glow stick is a chemical reaction that you start when you break the barrier between the reactants and allow them to mix. And as a product, as a byproduct in the reaction, light is formed. What would this be depicting? A new solid being formed. What do we call that new solid? A precipitate is formed. And there is one other thing that I see. What is going on here? A color change is also evidence that a reaction has occurred. What's going on here?
Fire.
That is fire. Chemically, what is fire? Like if you were on Jeopardy, the question would, the answer would be what?
Gas.
Energy is correct. And then there's one other thing. One other thing.
Gas.
One other thing. Energy is, thermal energy is correct there, or heat. And one other thing. One other thing. I demand you think today. Okay, if you were a caveman, why would you start a fire? Thank you. Okay, we already said that you use it for light. Fire is energy and light. Okay, what is this depicting? What evidence is this?
Burning.
A change. You know what? That is not my pen doing that. First of all, I can't move my hand that fast. I don't know what that is. But it's kind of driving me crazy. This is a change in temperature. And we call that change in temperature either exothermic or endothermic. Obviously, this one is exothermic. What is this trying to show you? Gas formation. Okay, we are now in high school. We don't say bubbles. Well, we do sometimes, but not for that. The other thing I want to show you is that this is wrong, starting off right. So I'm going to change it to nitrogen. I would like to show you this. These are the reactants. You have on this side 3 hydrogen molecules. Each one of those hydrogen molecules are bonded together because they're diatomic molecules. So this would be an H2. This would be an H2, and this would be an H2. These 3 hydrogen molecules containing 6 hydrogen ions are going to react with this diatomic nitrogen to form 2 ammonia particles, NH3 and NH3. The hallmark of a chemical reaction is what you start with is not the same as what you end up with. A new substance has been formed. Alrighty. Just a little bit to write down. All right, we're going to be talking about the formation of solutions, something called dissolving. Give me 2 words that would be useful if we were talking about solutions. Both start with S.
Starting.
No, but that does start with an S. Solvent is one, and somebody else can find the other. Solute is the other. Which one is being dissolved?
Solvent.
Solvent is being dissolved, and this is doing the dissolving. When a solution is formed, when a solvent dissolves a solute, it can be a process that is endothermic or exothermic. This endothermic one would feel hot or cold? Cold. Cold, because you, the surroundings, are giving energy to the system, which is the dissolving solute. Exothermic would feel hot. Now there's been a little controversy here. Is this a chemical reaction or is it not?
No.
Yes.
Okay, there's a controversy right there. Some people think yes, some people think no. At this moment in time, they're calling it ambiguous, which is neither yes or no. Okay, so let's look a little further and write this down now, and then we'll talk. Okay, here's fair warning. You're going to have to raise your hand and you're going to have to answer some questions. So, the person who raises their hand first with the easy answers, you're golden. I want to talk about covalent molecules right this moment in time. Raise your hand if you can tell me one thing about covalent molecules.
Starts with the C.
Nope.
Wasn't the AC?
Sometimes. So that is pushing you into, here, let me refresh your spring break brain.
Involve a metal and a non-metal?
I will ask for that answer in a moment. So, covalent molecules are
Both.
2 non-metals. Thank you very much. That was like pulling teeth. Covalent molecules, 2 non-metals, or a non-metal and a metalloid. What's going on with the electrons? They are sharing. You're sharing electrons. Okay. Now, ionic compounds
Involves a metal and a non-metal?
involves a metal and a non-metal. What's happening to the electrons?
They're unequal. Oh, wait, no.
They're really, really, really
Stealing
unequal.
them.
They're stealing. It's
Oh, okay.
complete transfer of electrons. Okay. Got that over with. For real. All right, now I want you to know this part. A covalent molecule, when it dissolves, does not break up. Here is a covalent molecule known as sugar. bonded together are carbon, hydrogen, and oxygen. It's C6H12O6. When you put sugar into water, does it dissolve?
Yes.
Of course, you've all had Kool-Aid. You just did. I'm fairly certain, even if you just put the Kool-Aid powder in your face and then added water, it dissolved on the way down, didn't it?
Yes.
Has anyone ever done that? Of course you have. You've never done that?
No.
No.
I've also never
What is
spelled.
wrong with you?
Why is sugar spelled with an E?
Huh?
Oh no, I can't. I'm not responsible for that. I was so happy to find this picture on the internet. I was like, yay! Okay, so what I want, back to this. Here is a picture of what's really happening when something dissolves. We have the sugar molecule, which is the solute. There it is, all hanging around together. And then we have the solvent, which is water, all hanging around together. In the act of dissolving, what happens is the solute becomes completely surrounded by the solvent. Got that part? Completely. However, this little packet of solute, in the case of a covalent molecule, consists of 6 C's bonded to 12 H's bonded to 6 O's. Got that part? We are clear. Now, if you take some salt, I do not recommend this, although I have done it. Put it in your mouth and throw in some water. Will it dissolve?
Yes.
Yes.
Oh, dude.
Ew, don't do that.
Yes.
Don't do that. Okay. It
What?
will dissolve and it will also ionize. Ionize is a fancy chemical term for break into ions. So, it dissolves in the same manner. You put the solute in there, it gets surrounded by the solvent. However, these little portions are actual ions. This would be a sodium ion. This would be a chlorine ion, surrounded by the solvent, which is water. Water. Okay. So the forces of attraction are actually doing the dissolving. This is considered a chemical change. Why? Hey, you know what? You should have known this from junior high. You could tell the difference between a chemical change and a physical change. How?
They don't look the same. Or can't be put back together.
They can't be put back together. In a chemical change, you can't put things back together. Could you put this back together? Oh, probably. But now that you're in high school, we're talking more about the amount of energy that's exchanged when this happens. So there we go. Do you need to know that right this moment in time? No. You know. Just don't put salt in your face and then add water, would you? Okay. Your little study buddy says the law of conservation of matter. Actually, or energy. We're talking about the law of conservation of matter. We're talking about the law of conservation of energy as well. Okay, ladies and gentlemen. So here we have a molecule of A, two A atoms bonded together. And then we have a molecule of B, two B atoms bonded together. These are called the reactants, and they produce the products. And you'll notice the same two A atoms appear in the product side. They have to. The same to be appear in the product side. They have to. Could you add a product C in here?
No.
Because it doesn't appear in the reactants. All right. So here in our energy diagram, this would be the reactants and these would be the products. Here are the reactants here, they have some energy. Here are the products here, they have some energy. Right up here is the activated complex. That's the reactants in process of becoming products. What type of reaction is this? Endothermic or exothermic? Here, I'll give you a hint. It starts with an E. Exothermic is correct. I'm sure you have to write this down. In Chem 2, whenever we start any problem, the first step is always start with a balanced equation. So it doesn't matter if it's hard, easy, or absolutely impossible. The first thing I say to kids is, well, start with a balanced equation. And from now on, after today, your first step in doing anything will involve starting with a balanced equation. For an equation to be balanced, the type of atom and the number of atoms must match on both sides of the equation. All right. Moving on, let's see how this is accomplished. You do not have this one. Don't be writing anything down. Please pay attention. This is a balanced chemical equation. Let's just for fun talk about the names and some of the other things in this balanced chemical equation. What does this mean? Yes, yield. What is this number called?
Subscript?
Subscript. What is this number called? Coefficient. What does this mean?
That's the state of matter.
State of matter. So if I were to draw a diagram of what this looks like, I would have the diatomic molecule, hydrogen, H2, and I would have two sets of them, yes? And then I would have the diatomic molecule, oxygen. I have one set of them. Remember, chemists are incredibly lazy. They never write the number 1. Is it there? Uh-huh. In the product side, I would have two molecules known as water. Okay. So you can see I have 1, 2, 3, 4 hydrogens, 1, 2, 3, 4 hydrogens, and I listed that right here and right here. On the reactant side, I have 2 oxygen, and on the product side here, I have 2 oxygen. Therefore, this is a balanced equation. Write yourself a note right now. I don't care where you write it, on your paper, on your neighbor, on the side, upside down. You may balance by changing, and this has to be in capital letters, yelling at you, coefficients. Then somewhere else write in big capital letters. Leave subscripts alone. 4 exclamation points. I really want to know what's with the shaking cursor. Okay. Here we go. We'll do this one together. You have this in your notes. This is what I'm going to do. I'm going to divide this up, making a T-chart. And the T-chart has two sides. Pretend that's a straight line. The reactants and the products. Step one is to just write down the type of atoms that you see. I see 3 types of atoms. I see an hydrogen, I see a
Oxygen.
sulfur, and I see a,
Oxygen.
by virtue of the law of conservation of matter, there better be hydrogen, sulfur, and oxygen on the same side. And there are. Here's the hydrogen, here's the sulfur, and here's the oxygen. My next step is to just count them. How many hydrogens do I have? 2. How many sulfurs do I have? 2. There's 1 here and 1 here, so I have 2. And how many oxygens do I have? 2. That's it on the reactant side. Let's go to the product side. How many hydrogens do I have? 2. How many sulfurs do I have? 1. How many oxygens do I have? 1. Is this a balanced equation? No, because while 2 equals 2, 2 and 1 are different and 2 and 1 are different. I cannot, under any circumstances, put a 2 here, can I? Nope, you're breaking the laws of the universe and you cannot. The only thing you can do is change the coefficient. And I'm going to do that right now by putting a 2 here. That means my sulfurs are now balanced. Is that correct? Okay, that worked really well for the sulfurs. Should I try again for the oxygens?
Yes.
Okay. I'll put a 2 here.
Oh.
And now I have 2 oxygens, but what else do I have?
4 hydrogens.
I have 4 hydrogens. Youch. Okay, well I can fix that really quick. How? Put a 2 here. Okay, so now I have 4 hydrogens. How many sulfurs do I have?
2. Or no.
3.
3. I have 2 from this compound and this one that has not changed. So now what should I do?
Change the 2 to 3.
Okay, all right. So this is no longer good, so I'm going to put this a 3 there. Okay, okay. Now it's balanced. How can I tell? 4 equals 4, 3 equals 3, 2 equals 2. What have we learned in balancing equations? First of
3.
all, use a pencil. Secondly, why? Because in balancing one atom, you may unbalance another atom, and this could be a multi-step process. Can you do multi-step processes? Sure. Okay. Let's try one more. And first step is to
List.
list the atoms. What kind do you see? Iron and
Oxygen.
Hydrogen.
okay, I'm going to list them in the same order on the other side. And then I'm going to do some counting. How many irons do I have in the reactants?
2.
Oxygens,
3.
hydrogens.
2.
And in the product side, irons,
1.
1, oxygen, 1, hydrogen, 2. Is this a balanced equation?
No.
No, it is not. So how shall we balance?
Put a 2 in front of H2.
Put 2 iron on the product side.
Okay, doesn't matter where you start. I'll do this. All right, now what?
Put a 2.
Put a 3 in front of the H2O. So that makes this a 3 and this a 6. 6.
Put a brand.
Okay, so I'm good here, and I'm good here, but I'm not good there, so I need to come back here and do what?
Put a 3 in front
Yeah,
of each.
put a 3 in.
Put a 3 in front of the H2, that makes this 6. 2 is equal to 2, 3 is equal to 3, and 6 is equal to 6. Is this a balanced equation?
Yes.
Yes, it is. Okay. You need an elbow partner, and you need a piece of paper between you. Yeah. Okay, ladies and gentlemen, you now have 2 minutes to balance these 2 equations.
As a group,
Who's your elbow partner? Oh, yeah.
Put a 2 in and that should be.
Ooh, look at you not doing any inventory. Looky, I hope that works out for you. Excuse me, shh. Obviously, you don't need this much time, or so you think. Ladies and gentlemen, how many of you got this far? And you knew this is good, this is. So you put a 2 in front of here, making this good, but changing this 2. So now this is good, but this isn't good. All right, put a 2 here, that makes this good to go. Everybody agree with this balanced equation? I would like to ask you, answer a question for me, please. If I started out with 37 grams of this, and to it I added, oh, I don't know, 23 grams of this, how many grams of this would I make? How do you know that? Because you can have less or more. So that is correct. You would have 60 grams of that. Okay. Now, here we go. Hurrying up, we have zinc, hydrogen, and chlorine, found it on the other side as well. How many zincs?
One, 2, 2.
Not balanced, but it's pretty easy to fix, isn't it? 2 here, and done. If I started out with 30 grams of zinc, and I knew I ended up with 22 grams of hydrogen gas, and 14 grams of zinc chloride, how many grams of hydrogen chloride reacted? Hydrochloric acid reacted.
6.
Well, wait, first of all, I have to do 22 plus 14 is 36 grams. So I know that total, I have 36 grams here. So this plus this has to equal 36. So this must be 6 grams. Everybody good there? All right. One more slide, and then we're done with that. Well, sort of. We have some homework to do. Okay, ladies and gentlemen, going to finish in a big way. You're right, nothing yet. Nothing yet. Are you writing anything yet? No. Okay, ladies and gentlemen, you're going to be responsible for the different types of reactions. There are several. This is chemistry, and you will